And the book we are going to skim today is about problem solving in data structures and algorithms. It's about problem solving skills and developing problem solving using data structures and algorithms. What language are we going to use is C++. Why? Because it's very similar to Java, to Dart, to many other languages. If you learn data structures and algorithms in C++, you should be able to learn them in all other languages. So let's kick it off and start the skimming of this book. This book is 585 pages. It's the first edition, first printed in 2016. And this is the book cover, right? So this is the memory of first in, first out. This is a stack memory that's first in, last out. And by Hemant Jain or Jane. Problem solving data structures and algorithms using C++ first edition. And here's the year. All right. Let's keep going. Acknowledgement. Table of contents, table of contents, table of contents. All right, so let's go through the table of contents. How to use this book. See, just like in programming, they start with chapter 0, because in programming we start from 0. We have, when we put counters, we write the 0, so we have chapter 0. How to use this book. What this book is about, preparation plans and summary. This is just chapter 0. Chapter 1 is about introduction, programming overview. Introduction, first C++ program, object, variables, parameter passing, call by value, parameter passing, call by reference, parameter passing, call by pointer. You can call a function, then you can pass a value of a variable. You can call a function and you can pass a reference to that variable. And you can call a function and you can pass a pointer. You can also pass the function itself by its value, by its name, or by its reference, or by its pointer. So the variable is treated like that, and the function itself can be treated like that. And the same for the class. You can pass the class by value, by reference, or by pointer. Kinds of variables, methods, access modifiers, abstract class, relationships, general prototype of a class, nested class, enums, enumerators, constants, conditions and loops, arrays, vectors. Oopsies, it keeps bouncing. I keep clicking the table of contents by mistake, so it jumps to the real topic. I will stop doing that. Okay, sorry about that. Variable, we've been through that. Arrays, vectors. What is the array and what is the vector? Array, interview, questions. Concept of stack. What is the stack? System stack and method calls. Recursive functions. What are recursive functions? And we have exercises. Then we move to chapter 2. See, chapter 1 is rich. Chapter 2 is even more rich of information. Algorithms and analysis. Asymptotic analysis. Big O notation. Omega notation. Theta notation. Complexity analysis of algorithms. The complexity order. Deriving the runtime function of an algorithm. the complexity examples, master theorem, modified master theorem. And that was chapter 2. Chapter 3 is about approach to solve algorithm design problems. Approach to solve algorithm design problems. We have the introduction, then we have the constraints, idea generation, complexities, coding, testing, example, summary. Looks like the development cycle that starts with an idea, then implementation, then testing, and then analysis, then testing, then implementation, then testing, then updating or enhancing, then goes back to the same cycle, similar to that. All right, abstract data type, C++ collections. Abstract data type, ADT, data structure, C++ collection framework, array, linked list, stack, queue, tree, binary search tree, priority queue, hash table, directory symbol table, graph algorithms, sorting algorithms, counting, sort, and not. And we have chapter 5 about searching, introduction. After the introduction section, why searching, different searching algorithms, linear search, unsorted input, linear search, sorted input, binary search, string searching algorithms, hashing and symbol tables, how sorting is useful in selection algorithm, problem in searching and exercise. Then we have sorting, introduction, types of sorting, bubble sort, modified, improved bubble sort, insertion sort, selection sort, merge sort, quick select, bucket sort, centralized bucket sort, heap sort, tree sorting, external sort, comparison of the various sorting algorithms, selection of best sorting algorithms. Linked list. What is the linked list? Introduction. Linked list. Type of linked list. Singly linked list, doubly linked list, circular linked list, doubly circular linked list. Then we have chapter A, the stack. After the introduction, we have the stack, abstract data type, stack using array, growing, reducing capacity, implementation. Stack using linked list, problems in stack, pros and cons of array and linked list implementation of stack, uses of stacks. Chapter 9, queue. After the introduction, we have the queue abstract data type, queue using array, queue using linked list, problems in queue. Chapter 10, tree. Introduction, terminology in tree, binary tree, types of binary trees, problems in binary trees, binary search tree, problems in binary search tree, exercise. Chapter 11, priority queue, introduction. Then we have the types of heap, ADT operation, operation on heap sort, uses of heap, problems in heap, and exercise. Then we have the hash table. After the introduction, we have the hash table, hashing with open addressing, hashing with separate chaining, count map, problems in hashing. Then we have the graphs in chapter 13. After the introduction, we have the graph presentation. We have the ADJA, adigency matrix, adigency list, graph travels, depth first traversal. Then we have the breadth first traversal, problem in a graph, directed acyclic graph, topological sort, minimum spanning trees, shortest path algorithms in graph. Then we have chapter 14, string algorithms, introduction, string matching, dictionary, symbol table, problems in string. Then we have chapter 15, algorithm design techniques, introduction, the brute force algorithm, greedy algorithm, divide and conquer, decrease and conquer, dynamic programming. Reduction, transform, and conquer. Backtracking, branch and bound, A algorithm, and conclusion, A star or A algorithm. Then we have chapter 16, the brute force algorithm, problems in brute force algorithms. Then we have chapter 17, greedy algorithms, problems on greedy algorithms. Then we have chapter 18, divide and conquer, decrease and conquer. And we have general divide and conquer, recurrence. We have master theorem. We have problems on divide and conquer algorithm. Chapter 19 is about dynamic programming, problems on dynamic programming algorithm. Chapter 20 is about backtracking and branch and bound. Then we have chapter 21, complexity theorem and NP completeness. We have decision problem, complexity classes, class P problems, class NP, class co-NP, and so on. NP weird or hard, NP complete problems, and reduction. Chapter 22 is about the interview strategy, introduction, resume, non-technical questions, technical questions. Chapter 23 about system design process, scalability theorem, design simplified Facebook, design a shortening service like ability, stock query server, design a basic searching database, duplicate integer in millions of documents, Zomato, YouTube, design IRCTC, alarm clock, design for elevator and of a building, valet parking system, or design for a McDonald's shop, object-oriented design for a restaurant, object-oriented design for a library system, suggest a shortest path, appendix and index, and that's it. That was the table of contents. Chapter 0, how to use this book.